Good evening, everyone. I hope you are all doing great today. A very warm welcome to each one of you to this free masterclass on GD&T. Let's unlock the language of engineering drawings through unique measurement service. Is it the screen is visible for you all? Okay. So let me introduce myself. I'm Dr. Gifty Evangeline here, General Manager of Unique Measurement Service, your host for today's session. We are happy to see such an enthusiastic group of professionals from various across all the industries who have been over here. Let me walk you through a few quick rules to make this session smooth. Please keep your mics muted during the presentation to avoid background noise. Feel free to drop your questions in the chat box anytime. So also we have a dedicated question answer session at the end. So this session is being recorded, and yes, don't forget, special offer is waiting at the end. So let me have a short intro about Unique Measurement Service. So Unique Measurement Service were established in 2015. We are the largest industrial measurement and calibration testing scanning service provider in India. We have nearly 16 branch offices. Our head office is located in Padi, Mannurpet, Chennai. So we use advanced measuring machines with a high accuracy, high precision, and fully automated machines. So our major services are CMM inspection, portable CMM, which is on-site inspections, laser tracker inspection, calibration, reverse engineering. We also do metrology training courses. Vision 2030. So our vision is and motto is to train 10,000 plus engineers freshers with placement. As of now, we have been training nearly 25 to 40 freshers monthly with 2 batches. We have exclusive training center at Bangalore Pina location. So our motto is to give train the freshers. Even we also provide the paid versions of the advanced level of courses also for the quality control engineers. Now it's time to introduce the persons you have come to learn from UMS. Our trainer for today is Mr. Tamil Paradi and Mr. Joshua. So both of them are highly expert in the field of metrology. They have more than 10 years of hands-on experience. At UMS, we have conducted over 30 plus workshops and trained 500 plus professionals across India in last 8 to 10 months. So UMS is known for deep industry insights. So this session will give you a strong foundation in GD&T, why it matters, how it is used in the industry, and how it can help you to stand out in your career. So get ready to decode the language of engineering drawings. Let's begin our session. And I assure you, it's going to be an insightful, interactive, and definitely worth of your time. And moreover, today you will be learning the basics of GD&T, the basic concepts, how the real world cases can be correlated with the GD&T. So there will be next 2 levels also. So in upcoming weeks, you will be in advanced level, you will be learning out. So over to the training now. I'm just handing over this to the trainers.
So good evening, everyone. I'm Tamil Paradi, and I have been working as a branch manager for the past 3 years here. So before start GD&T, let's we talk about some basic quality topics that are important for GD&T. Here the some contents are here. So first one is describing shapes and then types of drawing and then engineering drawing overview, then future control frame and datum reference frame, and then tolerance zone in GD&T and what is GD&T and which standard we are using for GD&T, and then why industry needs GD&T, and then GD&T symbols and conclusions. So first one is what describing shape. Yeah. What is shape? Shape is very important because without understanding shapes, we cannot identify object. So here the definition: a shape is a graphical representation of an object, form or its external boundary, outline or external surface. So everything we see in the world around us as a shape. We can find different basic shapes such as the two-dimensional and three-dimensional shapes. Now we will discuss about two-dimensional and three-dimensional shapes. So what is two-dimensional shape? So it has two measurable dimensions, which is length and width. So we can call as length is x and width is y. So here is a 2D coordinate system is there. So I will show how it will work in futures. This 2D coordinate system works with two coordinates for each point, like x and y. For this two coordinate function to define any points or object. If I will draw here on 2D coordinate system, so here it is x and this one is x minus and this one is y and this one is y minus. So you can find so x-axis and y-axis is a functioning here. So it don't have any depth or heights. So next one is 3D. So in 3D, it has three measurable dimensions like length, width, and height or depth. So here I mentioned some 3D shapes, which is a cylinder, cone, sphere, and cube, and cuboid. So 3D objects occupy space and have some volumes. So if someone will ask what is the difference between 2D and 3D, you can tell 2D is a two-axis measurable dimension and 3D is a three-axis, which means X, Y, Z. Three-axis will perform. So next one is type of drawing. There is two type of drawing is there. So one is artistic drawing and then a technical or engineering drawing. So coming to artistic drawing, uh, it is the art of creating image by making marks on a surface. Using a pen, pencil and ink, you can draw visuals of everything you have seen. So you cannot get any technical information from this drawing like dimensions or some material properties. So it is one type of thought expressions. So this drawing purpose is to express creativity and convey emotions or represent scenes or objects and visually. So next one is technical drawing. So our engineering drawing will represent of an object used to communicate design intent clearly and precisely. It follows some standards and rules and symbols to convey the size, shape, material, tolerance, and manufacturing interest for engineering components. And this type of drawing helps to produce component because it provides all technical data like dimension, material requirements, and units. So this drawing purpose is to communicate how a part should be measured or assembled. So here I attached one sample engineering drawing for you. So in engineering drawing, it consists more details like frame, title block, revision block, bill of material lines and views, some cut section views and tolerance tables, etc. So let's start from frame. So frame. So you can see here, right? So in edge we have some scale. So that is called frame. So generally the frame provides a visual boundary and make it easy to identify the dimensions and content. By using this frame, we can find specified dimensions or features on the drawing. I will give one small example. So I inspect one customer part using a measuring equipment. I can check all dimension except one, which is 5 mm, 5 mm length. Due to unreachable, so we can't able to measure this. So we just imagine like this. So I would like to communicate this matter to my customer. So I call my customer and told him that 5 mm distance was not possible to inspect. Then he opened a drawing and noticed some of the dimensions are same like 5 mm. So you will consider this dimension and this one is 5 mm. You just imagine this. So at the time he get confused. Then he asked where it is the exact location of the particular dimension. So at the time I explained this 5 mm will fitted on E4, which means you can see here. This 5 will intersect with E location and 4. You can see if it is in here, if it is in this 70s, then I can call this one is seated in A and 3. For that we are using this frame, and then it's title block. Okay. So usually a title block will located at the bottom right corner. So here you can find. In this, it has essential information about the drawing. It helps to identify company name, part name, material, what type of material they are used, and the units, and who drawn this drawing, and who approved this, and what type of projection is there, and scale details, which scale they are using for this drawing. So some essential information you will get it from this title block. Next one is a revision block. For revision block, it helps to track changes made to a drawing. It ensuring a clear history of modification and approval. I will show how it will comes. So some of drawing you can identify. This one is revision block. So first one is revision. Some industries they will mention 1, 2, 3 like that they will mention. But some of industries A, B, C like that they will mention. So here revision A, here some description they are given. They are updated chamfer details on 9th date to 2nd month and 2022. So who made this updated? They are just mentioned here for short form, and that zone also they are mentioned which zone they are updated. So second one is diameter they are changed. So 10 mm diameter was changed to 12 mm diameter. So on 9th and 3rd month and 2022, and here they are mentioned some zones also. So for that purpose, we can identify some a revision block in drawings. So next one is bill of material. So frequently we can see this type of table in assembly drawings. While assembly gauges or pictures, it will helpful to organize child components and where they are assembled. So here you can see one table I attached here, and in this table you can identify the child parts details like part number, what is the part number, and how many quantities required for assembly, and what is the size of that overall size of that particular component, and which material. So every details it will comes. So it will very help to organize child components, and we can assemble easily. So next one is line. So we are using so many different lines here. So first one is construction line. So in this line, we are using for multiple views at the same items. At the time, we can use this one for, we are not getting any final drawings. In pre-final drawings, we can see this all. So we can use construction lines to prefer multiple views. And second one is center line. Center line used to indicate future's center axis. And then hidden line. It gives internal future information of parts. Any internal future is there, then they will mention, they will draw like this hidden lines. And next one is phantom lines. These phantom lines are commonly used to movement of a component. It shows original position to alternate position. Any movable area it will comes, then they will mention this phantom lines. And then next one is drawing lines. It represents the visible edge and outline of a object as seen from a particular viewpoint. And next one is break line. So break line will use for some of future cannot drawn fully at the time this break line are using. It is a long and straight futures. So we can use in very lengthy drawings. Next one is dimensional line. This line to indicate the size or measurement of a feature, and then leader line to specify feature or notes on the drawing. Next one is cutting plane. It is indicate the plane along which session view is taken. So next one is coordinate system. There is two types of coordinate system is there. First one is Cartesian coordinate system, and next one is polar coordinate system. So coming to Cartesian coordinate system. So Cartesian coordinates uses for use linear distance. Here only consider horizontal and vertical distance. I have a point here, so I need to find some distance from my origin. So if we consider this one origin is, so in x-axis it is 12 mm distance, and y-axis it is in 5 mm. So only linear distance we can use for this Cartesian system. I will show some Cartesian system related drawing here. We can find out here, here the 0 is there, my origin is here. So here too all dimensions are passed to my features. For example, this whole in from 0, from origin to x-axis 50 mm distance are there. So this type of drawing, it is a Cartesian coordinate system related drawing. So coming to polar coordinates. So I already know about that point already. We have in Cartesian distance, but without Cartesian distance, we have to find this point. So by using angle and radial distance, we can identify the this points without Cartesian coordinate system. So I will show drawing how it will work. So here is that. So here they are mentioned some holes, 8 holes are there mentioned. That hole diameter is 30, and they are mentioned some GD&T frame. So here we anyway we have to find a position for position for finding position. We need some coordinates for x and y coordinates. Otherwise, we need some radial distance, which means PCD or radius, and along with angle. So here we can get angle and radius. So by using this PCD and angle, we can able to measure this position. So next one is feature control frame. So in feature control frame, it is a rectangular box used in GD&T to define tolerance and how they apply to a feature of a part. This feature control frame is divided into compartments or blocks from left to right. So first compartment will be a geometrical tolerance symbol. So we are mentioning geometrical tolerance symbol. We have totally 14 symbols. Any of symbols we can apply here. So we just, for example, we keep position symbol, and then next one is diametrical symbol. They are shown, which is denoted as a tolerance zone. Which type of tolerance zone we are using for this position checking, and then next one for tolerance value. So what is the allowable limit for finding this position? So here they are mentioned 0.15, and next one is material modifier. So in material modifier, there is two types are there. One is MMC, which means maximum material condition, and another one is LMC. It is a least material condition. So they are mentioned here MMC. So they mention M. If it is least material condition, then they will mention L here. And then some of few drawings we can get this one, a projected tolerance symbol. So projected tolerance symbol. Next one is projected length. This projected tolerance is a modifier used to GD&T to control the variation of a feature that will be assembled with another component, especially when the feature extend out from the part like pin, stud, or thread holes. It ensures the actual assembled position stays within the acceptable limits. So purpose of projected tolerance is control the orientation and location, not just at the feature base. Through the height we can control this position. And next one, here they are mentioned primary datum and secondary datum and tertiary datum. This controller frame purpose is communicate how much deviation is allowed, shows which datum are used to inspect the features. So next one is datum and datum reference frame. So what is datum? Usually datum is used as a reference when processing a material or measuring the dimensions of a target. It is an origin from which the location of features of a parts are established. It can be a flat surface or holes or axis or plane. So this is the datum symbol. We can find this kind of symbols in our engineering drawings. So purpose of this datum, it gives as a reference for consistently measuring and locating part features. So next one is what is datum reference frame? Datum reference frame, it provides a fixed location for the parts or its features, allowing for accurate measurement and tolerance. This datum reference frame is a coordinate system composed of three or more datums, usually primary, secondary, tertiary. It will come. It ensures parts fit together correctly in assembly. So next one is shape of tolerance zone in GD&T. So earlier the tolerance zone was square in shape. So rejection were are high during the inspection. To avoid rejection, the tolerance zone was revised to circle shape. So here we can find out. So my target location is this exact point. But when I measured future, I get that future center point is here. So when I was used a square tolerance zone, at that time my part was rejected. So in same case, in this case, I applied to this circular tolerance zone. So once I applied this circular tolerance zone, my part was okay because it has 57% of area it will cover. It's compared to square tolerance zone, this circular tolerance zone will get 57% higher side. So in same case, when I used in circular tolerance zone, my part has okay. So coming to types of tolerance zone in GD&T, we are using 3 types of tolerance zone: unilateral, bilateral, and limited tolerance. So unilateral tolerance, so the tolerance allow variation in only one direction from the datum. So here you can find out. So 20 mm is the distance, and tolerance is in plus side. There is positive and negative. Only one direction only applicable for this, even positive or negative, anything. Okay, here 0 to tolerance allowable limit is 0 to 04. So allowable value is 20 to 20.04. And this one is for we'll take this one for dimension is 12 distance, and from 0 to minus side it is a negative side. So this one also is a unilateral tolerance type 1, and here some 100 diameter is there, and this one is a positive side unilateral tolerance one. So coming to next, bilateral tolerance. So in bilateral tolerance, two bilateral categories are there. One is equal bilateral and another one is unequal bilateral. In equal bilateral, we'll get tolerance plus or minus. In unequal bilateral, we'll get two different values, different signs. So here you can see 20 same, that 20 in minus side O4 is there and plus side O4 is there. This one is in same sign and same value. So this is the equal bilateral equal tolerance, and this one is 12, and but sign is different but value is same. So this one also equal bilateral, and then 10. See here. So in minus side 0.02 is there, in plus side 0.05 is there. There is two different values there. So it is a unequal bilateral tolerance. Next one is limit tolerance. So in limit tolerance, we can find some drawings like direct value they will given, like diameter 19 to 99.6 to 20.005. So allowable limit is 9. This in between values, that is the allowable limit. So directly they will give. They will not mention any plus or minus tolerance or plus signs. So in tolerance zone, in GD&T, we are using some different kind of tolerance zone. For line, we are doing some parallel lines tolerance it will create, and for cylinder parallel lines, parallel type of a tolerance zone it will create, and some of case, so plane parallel planes it will create when we are going to measure some planes. At the time, the tolerance zone will becomes parallel planes. And if we are going to take some cylinder, then cylindrical zone will apply here. So here too I will hand over my session to Mr. Joshua.
Myself Joshua. I've been working here for past 5 years as a trainer. Okay, finally we came into the point GD&T topic. So I hope everyone will understand previous topics. So with those topics, we can easily know about GD&T. So if you have any doubt or questions, you can put in comment box or message box. Finally, we can discuss about that. Okay, first GD&T. GD&T was invented and developed by Stanley Parker at 1938. He is also known as father of GD&T. So the full form of GD&T is geometric dimensioning and tolerancing. So it is a universal symbolic language to communicate manufacturers and quality inspectors. So it gives the clear communications of limits and tolerance. So it helps us to control and communicate variations, and it will ensure 100% function and fits. So implementing GD&T, we can avoid confusions, scraps, and reworks, which which result in a loss of business. So the main purpose is to communicate the clear communication and the intent of the manufacturing to the manufacturer. So GD&T standards. So ASME Y 14.5 is the GD&T standard. ASME means American Society of Mechanical Engineers, a non-profit organization. It is a non-profit organization. They developed and standardized this GD&T. And here 14, they have given 14. In GD&T, we have 14 symbols. For mentioning that, they have given 14. And 0.5 is in GD&T, we have 5 tolerance classes. For mentioning those tolerance classes, 0.5 has been given. So the GD&T standard is ASME Y 14.5. So here, what is the use of GD&T? With two examples, I will give why GD&T will be useful, and without GD&T, what are all the drawbacks they have placed before. Okay, here two drawings is there. So in left side, no GD&T were mentioned. So they are manufacturing the part with only the dimensional tolerance. So at the right side, they are making the part with GD&T. So in left side, they are maintaining the distance 25, but they are not controlling the feature, because before GD&T, there are no clear communication about the feature. So they maintain the dimension, they control the dimension, but in assembly there will be the air gap due to the form error. So due to those form error, the part will not fit nicely, and due to air gap, leakages will be there. So in traditional method, only dimension will be controlled. In GD&T, there is a clear communication about flatness of the plane. So the feature form is controlled, well controlled. During assembly, it will assemble nicely and smoothly. So here with GD&T, we can control dimension as well as the feature. So it is the plus point. So next, in this scenario, how GD&T will help in assembly, function and fit. So left side, they are using without GD&T, normal traditional dimensioning, and right side, they are using GD&T position. So here, left side, in traditional dimensioning method, the tolerance zone will be a rectangular tolerance zone, and with GD&T, the zone will be circular. So here below, the circular tolerance zone is 57% larger than the rectangular tolerance zone. So manufacturer can get a wide tolerance zone, so the part rejection will be reduced. For example, here exact theoretical position is in center here, but the part actual is located here. So in traditional method, the part will be rejected and rework will be done, and due to the rework, production will be stopped. So in GD&T, the part is outside the rectangular zone, but it is inside the tolerance. So the part is not rejected. If the actual value gets outside the tolerance zone, circular tolerance zone, then the rework will be done. So here, comparatively, we can get a wide tolerance, so the rework is not there. The part rejection will be less, and it is easier to manufacturing the part. So the main purpose is, it defines the process of production and inspection. Tolerance restrict the worst case condition. it ensures all mating parts fit nicely together, and it is a universal language which we can collab easily with various countries. So the next, we're going to GD&T symbols. So we have 5 classes: form, orientation, profile, runout, and location. So we can easily remember in the shortcut FOPRL. So in form, straightness, flatness, circularity, cylindricity will come. Okay, you can see here in this slide. So this tolerance of form is independent feature because no need of datums. So for form, there is no need of datum, so it is called as independent feature. Next, orientation, angularity, perpendicularity, parallelism. So for this tolerance, we need datums. So this is dependent features. Next, profile. In profile of line and profile of surface. So in this tolerance, we may or may not need datums. So it depends upon the process. So it is a dependent or may not be a dependent feature. So this is location. In location, true position, concentricity, symmetry will come. Without datums, we can't know where the location is. So it is a dependent feature. So next, runout. In runout, circular runout, total runout. So we need datum. So it is a dependent feature. So now we're going into the topic tolerance of form, straightness. So this is the scenario of the part. In right side view, you can see it in isometric view. So in one linear axis, they have given 0.5 tolerance, and another linear axis they have given 0.1 tolerance. So this is the symbol of the straightness. So here the definition is straightness is the condition where an element of a surface or an axis is a straight line. A surface is to be in a straight line. We're going to control the deviation of the straight line. In the next slide, you can get clearly. So the tolerance zone has been separated by the 2 parallel lines. You can see the waviness. This is the deviation of the straight line. So if the waviness went outside the 2 parallel lines, then it is out of spec. So the part will be rejected. And if this lies below the 2 parallel lines, then the part will be okay. Part is okay. So here, how we will calculate the value? So here you can see the maximum point is 25.25 and the minimum point is 24.75. So we can calculate maximum and minimum, and we can. So the value is lesser than this tolerance zone 0.5, then it is located in the 2 parallel lines. If the value went above the 0.5 means, then it went above the 2 parallel lines. So here you can get only the one linear axis waviness. Now we can go to another scenario. This is the scenario, a cylindrical job. In this cylindrical job, in one linear axis, we're going to check straightness. Here you can see the drawing. It has given here in this line we're going to see straightness. Here you can see the tolerance zone has been separated. Here the waviness of the cylindrical job must lie within the tolerance zone. So wherever we can make a line, there we can check control straightness. So manual method of checking straightness. So here we can keep dial gauge in a part and setting 0. So here a dial gauge has been set at 0, and then translation must be done in a linear axis movement. So in this arrow mark you can get. So the dial will move in a linear translation. So we can get this variation. And the value will be noted. If the value went above the 0.1, then the part is deviated. If the value lies below this tolerance zone, then the part is okay. Okay, next, flatness. So for flatness, same like straightness, but we're going to check in two linear axes. Here, this is the side view. In next slide, there is a 3D view. Here, the tolerance zone has been separated by the two parallel planes. In straightness, the tolerance zone will be separated by the two parallel lines. Here in flatness, the tolerance zone will be separated by two parallel planes. So the zone is shown here, and the waviness of the part must lie within the two parallel planes. So here also same calculation will be done. So the maximum deviation minus minimum deviation, we can get the value. So the value must be below this tolerance zone. If it is in below this tolerance zone, the part is okay. And if it went above 0.1, then it went above the two parallel planes. So this is the manual method of checking flatness. Here we will move the part or dial gauge in both the axes, linear axis. So we can get two linear waviness. In straightness, we can get only one linear waviness. So this is the difference between flatness and straightness. And next is circularity. So here, this is a cylindrical job. For this, tolerance is 0.1. Circularity, we're going to check in the surface. So in this surface, in particular cross-sectional, we can get a circle. So circularity is geometry which is two-dimensional and rotary in nature is called circle. The control of circle is called circularity. It has been also called as roundness. Here you can see at the right side the actual part deviation. Here the tolerance will act like a two concentric circle. The waviness of the circle must be lie within this two concentric circle. Here the overall tolerance zone is 0.1. So you can see clearly. So the manual method will be same like straightness, but here rotation will be done. Instead of translation movement, the rotation will be done. The part is said to be rotating at 360 degree, and then the linear waviness of the circle is measured. Same dial gauge is set 0, and the part is said to be rotating around the central axis, and the dial gauge records the variation of the surface. The dial gauge must have a total variation less than the tolerance zone. If the record is went more than this 0.1, then the part is deviated. It went out of the two concentric circle zone. So here now cylindricity. So here same geometry which is three-dimensional and a rotary in nature is called a cylinder. A control of cylinder is called cylindricity. So here in circularity only waviness will be considered, not this form will be considered. Only the circular waviness will be considered. In cylindricity, the waviness as well as the straightness will be considered. Why? Because the zone will be like concentric cylinder. So here you can see the manual method. The part is said to be rotated 360 degree and the dial will move in a linear direction. So we will get the circular waviness error of the part as well as the straightness error also it will be considered. So the It is measured by constraining a part, rotating and as well as translating around the central axis. And dial gauge records the variation of the surfaces. If it went high above this 0.1, then the part is out, and it went below, it is between these two concentric cylinders, then the part is okay. So what are all the features will affect the cylindricity, concentricity error? So if they are not maintaining this form in assembly, air gap will be there, and fit is not perfect. So if any fluid pass through the pipe, leakages will be happen easily. So for restrict that, circularity, cylindricity plays the major role. Okay, I'm going to wind up the topic. Next week we will be continue the further topics. So if you have any doubt, you can